All right, welcome back, everybody. We are working on the Chapter 2 exercises this week, and the first of the Chapter 2 exercises is Exercise 4, which is named Quarts to Gallon. And so the instructions are, write a program that declares a named constant to hold the number of quarts in a gallon, which, by the way, is 4, if you didn't know that. Also, declare a variable to represent the number of quarts needed for a painting job and assign an appropriate value, for example, 18. Compute and display the number of gallons and quarts needed for the job and an explanatory text with the values. For example, a job that needs 18 quarts requires 4 gallons plus 2 quarts. And really what they're trying to push you towards here, by the way, is whenever you're putting output to the screen for your user, it is really good to be verbose and precise and probably provide more information than what they need, and in some cases say it more than one way so that you make sure that the message is delivered clearly. And that can be interpreted in many ways. Some people will just say, we'll just put the number 18 on the screen, but my preference is that you actually say a message with it somehow. All right? And the book is really pushing you towards that as well. Okay, so since we need to get this first part of the equation or the exercise in place, let's go ahead and save that file that we just created before. So I have already preemptively launched JGrasp, by the way. The other thing that I did is I made sure that I had a folder pre-created, and you see I'm working on my G drive, which is my Google Drive. I have a folder for my class, and then a folder for the semester, and then a folder for the chapter. And then I'm navigated in the sidebar here to that location so that every time I save a new file, it will automatically drop in here. All right, so that is step one. A lot of people will do the file management externally and then open up that location. But I would implore you to find that location here before you proceed with your work. All right. Now that I already have a pre-created new file here, I'm going to begin by creating the public class statement, not there, sorry, here. Now you see what just happened to me, right? So now I have to go back. All right. Fortunately, they have a back button. So public class, and they wanted us to call it quarts to gallons. And they have it in camel casing like this, capital Q, capital T, capital G. And since we are declaring the public class, I'm creating my opening and closing curly brackets straight away. Okay. Now I'm ready to add my main method inside of there. I'm going to come down one line, leave it blank, and now create my main method. And this is one, remember, you should try to memorize this statement. Public static void main. Inside the parens, you will say string with a capital S, square brackets, and args. This is required in every Java program that needs to execute with an opening and closing set of curly brackets. All right? This is the first step. Now, we need to follow the instructions. So one of the first instructions was that we declare a named constant, which is a form of a variable that cannot change. Right? So we know that if we were to create a variable, we might do something like this. We might say integer and then give it a name, sort of like quarts, and I'm being very verbose here, in gallons. And there's this convention in Java that when we name something all uppercase, it's a constant, and we separate the logical words with underscores. Convention, not a rule, by the way, but it seems that most programmers follow that across all languages. We will add the keyword final in front of it to indicate that this is a constant. So in other words, there is nothing in the program that can change this value that we're about to assign because we're setting it as a final value. It's final equates to a constant. We are going to pre-assign a value because we know there are 4 quarts in a gallon. So we're just going to say that up front. And then every time I want to use the number 4 in a calculation, how many quarts are there in a gallon, I'm just going to call this name every time I need that value. That is a little verbose, but here's the kind of general rule in programming, by the way, especially in modern programming. They prefer that you use verbose names for all the things that you're creating so that somebody else looking at your code later can understand what's going on without having to, like, trace down all your code and maybe call you on the phone and go, what does Q stand for? So it's better to use quarts and gallons to spread out the whole thing. All right. The next thing that we need to do is we need to figure out how to calculate all this. All right, so I want to go back and read this because I wasn't really clear on this. It says, write a program that declares a number of total. Also, declare a variable to represent the number of quarts needed for a painting job and assign an appropriate value, for example, 18. And so what they're really telling us is they want us to kind of predetermine this to begin with. So the second part of the program is going to allow the user to enter a value. The first part of the program is just to get the program to work. That's what the difference is here, folks, by the way. So here's how I'm going to begin. I'm going to create a variable following this one, and I'm going to call it an integer. And I'm going to say the total quarts I need. And I'm going to talk about the value that I'm going to put in here, because the book is saying, for example, 18. So I'm going to put 18 in. Okay, so the total quarts we need, for example, might be 18. All right. The reality is now we need to calculate, based on the number of quarts, how many gallons we need, and then whatever doesn't fit into a gallon would then have to be purchased as an extra quart. So if any of you that ever buy paint, right? Like if you go up to like Sherman-Williams, you can usually buy your paint in a gallon, or you buy it in a quart. And if we know there's 4 quarts in a gallon, it's sometimes silly to buy 4 quarts if you have a gallon, because the gallon thing is cheaper, there's less packaging, and they save you money. And then professional painters also know that if you get up to 5 gallons, you can get the 5-gallon bucket, typically, too, and that saves you even more money, right? So a lot of pro painters buy big 5-gallon buckets, but sometimes that's way too much paint. You're just painting a room. You don't need a 5-gallon bucket. So what we're trying to figure out is the most economical way, really, to buy the paint, in the form of, like, I'm going to get as many gallon cans as I can because it'll be cheaper than buying a lot of little quarts. But we're figuring out what we're doing in quarts to start with. And we're predetermining a value of 18 because the book said so. So the next thing that I need to do is I need to create variables that will hold some values that we're going to calculate. We haven't calculated them yet, but I'm going to create the variables for it now. So we're going to create one that says gallons needed, and I'm not assigning a value. I'm just creating, the memory space for it. I'm also going to create one that's going to be called quarts needed, and this will basically absorb the value of whatever doesn't fit into a gallon. So for example, if I bring up a calculator, and this is sometimes what you have to do, by the way, as you're calculating and figuring out programs. If I have 18 quarts, if I take the number 18 and divide it by 4, that will give me 4.5, which tells me I need 4 1-gallon cans, and then I have a half-gallon left over. Right? So it'll be cheaper to buy 4 1-gallon cans and then 2 quarts, and then I won't probably have any left over. All right, so let's kind of use that as kind of our thing. Now notice the math that I did. I divided the total number of quarts by the number of quarts in a gallon. And if you listen to how I said that really carefully, that is kind of the clue to writing this program. So here's what we're going to do. We're going to figure out first how many gallons we need. So I'm going to take that variable, gallons needed, and that value that we're going to put inside there is going to be the result of a calculation. So I'm just going to put one single equal sign. And remember, that's not an equal sign anymore. It's called an assignment operator. And whatever we do on this side of the equation, on the right side, will get assigned to the variable on the left, whether it's math or hard-coded. So we're going to begin with how many quarts we have total. Now remember, we preset this to 18. And then we are going to divide by that constant that we created, quarts in gallons. And really, I should have probably named it singular. In fact, you know what? I'm going to change my mind here because it's quarts in a gallon, not gallons, right? It just makes more sense in my mind. All right. So if I, once again, if I trace this down, this equals 18. This equals 4. Of course, I could write the equation. I could hard code the number here and hard code the number there. And it would still work. But this is considered a better approach, to refer to stuff instead of forcing it in. In the second program, we're going to allow the user to enter this value, by the way. All right. So now we know the number of gallons needed, because if, and this is the funny thing about Java, and you have to remember this, if I divide an integer by an integer, it's going to give me a value. And then that is actually going to resolve, because of the way that Java does math, it's going to resolve to a whole number. And then we have to figure out how many quarts we need on top of that, and that's going to require a different kind of math. So this is kind of interesting, especially for those of you that might be new to programming. We are going to determine the quarts that are needed in the aftermath of that, kind of in a tricky way. Because if think of this calculation I just did, right? I divided 18 by 4. What I'm telling you is this first equation, if we run it, is going to output simply 4. It's not going to give me the remainder. So now I have the problem, how do I determine this? And remember, this is remainder. So the remainder, there's a special form of math in Java called Modulus Division that will give us just the remainder. And you know, this is one of the reasons why we have it, by the way. The fascinating thing is it's basically the same equation. We're still dividing. So I'm just going to copy this and paste it down, but I'm going to change the math operator to a percent sign. And that tells it, don't tell me how many times 4 goes into 18. Tell me what's left over from that. That's what that sign does. Got that? So this will calculate out to 4, and this will calculate out to basically 0.5, sort of, right? But really, that's not the math that's going to happen here, because if you're doing it with non-decimal numbers, this will actually have a remainder of 2. So let me just show you how we can actually see the output of this now. And then hopefully it'll make a little more sense. We're going to do a system.out.println, which is the way we get stuff on screen, with our parens and a semicolon, and then we'll start by putting in some text. And so, following what the author asked us to do, a job that needs, and notice I'm concatenating now, this number of quarts total. And right now this value is hard-coded. We predetermined it. But in the next exercise, user will be entering that. That's why we're using a variable here. And a job that needs, this will come in as a number, and then I'll need some words to describe it. So this will say 18 quarts, comma, requires, and I'm kind of running out of space on this line here, I'm noticing. So I'm going to move down to the next line, tab in a little bit, and add a plus sign. That allows me to concatenate on the next line, so I don't have to keep going off to the right forever, by the way. Requires how many gallons? Well, that'll be the gallons needed plus text that describes it, gallons. And this is kind of a weird way to think, because you have to think of like what it's putting on the screen and what the words are saying on the screen. And sometimes, I'll be real frank, sometimes you put the numbers on the screen first to see that they worked, and then you add the words later. A lot of programmers work that way. And then we need the 4 gallons, which will what display here, and then the remainder. And so once again, I'm going to concatenate here quarts needed, and then add the text to it at the end, quarts, to describe it. And you know what? There's going to be times where you forget to put in the right stuff in the right spot, and that's kind of okay. But here's what the correct version of this program is. This is actually complete, believe it or not. Let's go ahead and save this, and let's be brave and give it a run. I'm going to stick with the name quarts to gallon. Apparently I forgot to do the save as, right, you guys? Well, here's the proof of it. I forget to do that too. But fortunately, it seems like it'll work out. Let's hit that run button and see what happens on the screen below. All right. A job that needs 18 quarts requires 4 gallons plus 2 quarts. Okay, that's the output that we want. Did everybody get that to work? All right, we're going to go to the second part of the exercise now, and I'm going to flip back over to the book listing here so we can just read it. And you're going to see that these exercises kind of proceed in this pattern for this chapter. It says, convert the quarts to gallon program to an interactive application. So instead of assigning a value to the number of quarts, accept the value from the user as input, and then save the revised program as quarts to gallon interactive. So I'm going to begin by renaming it first, and in fact I'm just going to copy this from here.
Read your screen?
Yeah, Dad, we can't see your screen.
Oh, of course you can't. You know, I will tell you the recording can see my screen though. So I'm just copying this right from the book. I'm going to flip back over now to JGrass. Thank you for pointing that out, by the way. And in JGrass, I'm just going to come up here and do a couple of tweaks. I'm going to change the title here, and then I'm going to come up here and do a save as, and it'll pick up that new title automatically. And remember, the name of the class has to exactly match the name of the file. That's a rule in Java. Absolutely required. Okay. Now we're going to start tweaking this, and the next piece really is to add the interactive components, which will have us pull from the command line from the user. So we're going to prompt the user to enter this value instead of having it hard coded. So for those of you that have done the You Do It exercises, you learned about this thing called the scanner, which allows us to basically scan the keyboard for input and capture it for use in our program. And that requires an import statement. So this is the way we import libraries in Java. And this is being pulled from the utility class, and we pull in the scanner tool. So this is one that you'll add to any program that requires user input. So it's import java.util.scanner with a capital S. Okay? And then, since we know that this value here is now not going to be hard-coded, I'm going to get rid of the pre-assigned value. Right below all the variable declarations, I'm going to add a line, and now I'm going to throw in the scanner. And so we call the scanner class, and then we give the object that we're creating a name. And very often we'll choose input, or some people will say keyboard, or whatever you want to call it. You can call it chopped liver for all I care, as long as the name is unique and not a Java reserve word. But input seems like a reasonable word to use for keyboard input. And then because of the process of how this tool works, you have to issue a statement that looks like this. Now, we haven't learned about what this means quite yet, but we will learn about this as we go into the next chapter, by the way. But we will just utilize the tool with just knowing this is how you do it, right? So you have to import the scanner up here, and then you have to declare a scanner object. And from here on in, we're really giving the scanner a name. So anytime we want to use the scanner, we just call the keyword input, and it will be utilized. We'll begin by actually putting a message on the screen. So we're going to say system.out.println, and of course the reason we're doing this is because we want the user to enter something. And what I'm going to do is I'm going to say, please enter the number of quarts, I guess this should be particular, of paint needed. And, I'm going to put a couple like little arrows in there too. You don't have to do that. I mean, you can put whatever you want. But I do suggest that you leave a space here at the end so what the person is typing isn't touching your words, because otherwise their letters will start right next to yours. And maybe even 2 spaces is better, or 3. I don't know. We'll see how it looks. On the next line, we're going to put a way to capture the input. Now, in general form, you usually say input dot and then declare the data type that you're importing. So since the data type we want to import is an integer, the command here will be next int with parentheses. And what that means is it will capture whatever is at the keyboard and convert it into an integer to feed into our program. But now the question is, we're grabbing it, where the heck are we putting it? It can't just go into nowhere. And so at the beginning of this line, what you really need to add is the variable name that you are about to store it into, which is going to be the total number of quarts, called quarts total, and an equal sign. So whenever you're grabbing stuff from the keyboard, whether it's an integer, a double, a string, whatever the data type is, you have to use the appropriate function name. We know it's an integer. They're probably going to enter a whole number. And then the variable will be on the left that will hold that value. So remember, this was hard-coded before. Now it's going to be dynamically entered by our user. Other than that, we really don't need to change anything in our program. Everything else will stay the same. The difference is this value isn't hard-coded. We asked the user for the value, we grabbed it from the keyboard, and then we just carry on with the program and do the same work. And so this is actually important to note that this is a good pattern of development. Often a programmer will figure out how to make the calculations work or the logic work first, and then they add the interactivity. The other thing that I want you guys to know too is as you move to the second Java class, a lot of times you'll have logic like this pre-created and you're putting a graphical interface on it. But you always start with the logic first. All right, so this is actually the completed program, folks. So I'm going to kind of move my thing out of the way here, try to get it all on the screen at the same time. So this is the whole program. There's a closing curly bracket down here. And I'm going to go ahead and give this a run. So I'm going to pull my console and make it a little bit bigger. I'm going to go ahead and straight away hit the run button. Now you guys notice I didn't save it. And some of you are like, save first, save first. But here's what happens. If I hit the run button, it automatically saved. Did you catch that? And I don't tell you that right away. I usually say Control S to save. And now, rather than running the program and completing it, right, now it's waiting for me to enter something. And then I'm going to talk about like an alteration to this in just a moment. So it says, please enter the number of quarts of paint needed. And I'm going to, I put in 18 last time. So, let's put in 18 again just to make sure that it still works the same. So I'm typing 18 and I'm pressing enter. It does the calculation and gives me the same answer. Now, let's test it a couple more times. You shouldn't just be happy with one run, by the way. And oftentimes, I always tell people when you're programming, you should know what output to expect with the numbers that you're putting in. So sometimes that requires that you go to a calculator or pencil and paper or even a spreadsheet or whatever tool you use to do your math and determine what the right output is. So this time I'm going to type 20. What should the answer be? 5 gallons, right? 5 gallons and no quarts. Let's test it again. And this time let me put in 3 quarts. So now it should be 0 gallon and 3 quarts, right? Okay. So it's working as I expected, but I always tell people, make sure that it's doing what you expect, because just because it's putting something on the screen doesn't mean it's the right answer, right? The math still has to be correct. And, sometimes we have to extrapolate a little bit on the math. And I always tell people, don't freak out on the math part, because whatever the equation is going to be, if you get stuck on it, I'll help you with it during these sessions. So please keep that in mind. The other thing is most likely you can probably Google it and find the right equation anyhow if it's not given. Real complicated ones are typically given by the book. Simple ones they expect you to figure out, like an average, for example, or the difference, or dividing, stuff like that. One little tweak I'm going to make here, and I want you to notice this because this is an important one, because most of the time we've been using this command, we use it just like this, and we include print line. And this is an important thing. Now you notice when I ran the program, the cursor was flashing below the line, but you might have been expecting it to be over here. And the way that you can do that is by just simply eliminating the ln. You can just say system out print, and then the cursor will wait here. So let's just run this again. So I'm just going to run it with the alteration and watch what happens. So now the cursor is here flashing, which is more of what you expect. And so now I'm going to type in the same value. This time I'm going to type in, 654. Let's give it a challenge. Well, let's make it not a number that ends in 4. Let's make it an odd number ending. And I'm going to press enter. And so I need 163 gallons plus 1 quart. And of course, if I was a professional painter, I would divide that 163 by 5 and buy 5-gallon buckets, because that would be even cheaper and more efficient. Okay. But that's the one way that you can put that cursor here, is by changing print line to print. And so knowing that, this tells you that the print command leaves the cursor at the end of the line when it's done. The print line command puts the cursor on the next line after. And this is something you can leverage to your, whatever you're doing. And in my thinking, I would expect the cursor to be here. So that's why I made the change. If you did it the other way, that's fine too. There's no real functional difference. Let's go to the next exercise. Let's jump over to the book and get our instructions. So this will be working on exercises 6 and 7, which once again are related. And this one is converting, let's see, we're converting miles here. What are we converting? It says, write a program that declares named constants to represent the number of inches, feet, and yards in a mile. Right? Also declare a variable to represent a number of miles and assign a value to it, just like we did with the paint program. So we're hard setting a value. Compute and display with explanatory text the value in inches, feet, and yards, and save the program as mile conversions. And so, interestingly, if you happen to be working with an older version of the text, and I don't know if anybody here is, this was a different exercise in the previous book where we were converting nautical miles to regular miles, and this one, and then over to kilometers. In this case, we're doing something a little bit different. And so I'm kind of flying a little more by the seat of my pants here. So I'm actually creating this one because I'm not looking at the author's solution. So let's see if I can know how to code, folks. All right, let's go ahead and let's cheat a little bit. And this isn't cheating, but I do want to name my file exactly this. So let's go ahead and copy that and go over to JGrasp, and let's go ahead and create a new file. So we'll go to File, New, Java. Right away, we're going to do a Save As, and we're just going to paste that name in here, Mile Conversions. Okay. Let's go ahead and get the public class created. Once again, I have this copied already, so I can just paste in the name, and then my opening and closing curly brackets. I'm going to come up to the top here. I'm going to indent one level with my tab key. And I'm going to put in our main method, public static void main. We go string with a capital S, square brackets, and then args. Semicolon there. Another set of open and closed curly brackets, like so. I'm going to get indented, and now I'm basically ready to start doing my work. Now, let's go back and look at the instructions really quick, because I very quickly forget. So it says, write a program that declares named constants to represent the number of inches, feet, and yards in a mile. Okay, so how do we know what these? I mean, how much is that? Does anybody know how much this is? Well, you know what, folks? They made this thing a few decades ago called Google, and so I don't expect you to memorize how many like feet there are in a mile. But we could search feet in a mile, right? And so it's 5,280. So let's go ahead and like we did with the other program, let's create a final. And this is also going to be an integer because this is going to be a counting number. And we're going to call this feet in mile. And that value was 5,280. How about the next piece, which is the number of, well, I guess we didn't do it in that order, number of inches. Do we want to say the number of inches in a mile? Does that make sense to do it that way? What do you guys think? Okay, no, let's do that. So if there are 5,280 feet in a mile, how many inches are there in a foot? And is that really what we need to do, is how many inches in a foot? This is the question. How many inches in a foot or how many inches in a mile? What are your thoughts? Anybody have a thought on this?
I personally just did the inches into a mile as a constant when I went ahead and coded it.
Okay, Larry,
It made it easier for me to think that way when
Okay.
I was plugging in all the equations.
all right, so if we know then, would you agree that if I know there's 5,280 feet in a mile, I can multiply this number by 12 to get the number of inches, right?
Yeah, that makes sense.
Okay, so let's multiply it, and we'll come up with the number 63,360. I better go over to JGrasp and write that down really quick. 63,360, because otherwise, I'm going to forget. But I already kind of know that I'm going to do this with it, right? I'm going to say final int, and we're going to say inches in mile. So it is 63,360. Now, the way that we came up with that, it's going to be similar to coming up with the number of yards in a mile. So once again, if we go back to that 5,280, how would we figure out the number of yards here? Okay, so the answer for that is divide by 12, right? No. Divide by what? How many feet in a yard?
I think it's about 3.
Okay. Yeah, it's exactly 3. Right? So there's 1,760 yards in a mile. All right, so I'm spelling all of these out, and then I'm going to point out something to you that might not dawn on you as a beginning programmer, but we are going to call this yards in mile. And what was that number? 1,760. Okay. So what I did is I went external, and I did these calculations externally. Okay. And then I came in here, and I created constants for each one of these to represent those values. But here's something that you guys really want to consider about this very carefully. And beginning programmers will not think this way, but experienced programmers do. If I'm going external to do a calculation to determine what these values are, couldn't I have just done that calculation here? And here's the answer to that. Absolutely yes. And so I'm going to give you an alternate version on how to get all of these. And so one of these has to be a given. So what we start with as the given is 5,280 feet in a mile, and then all the other calculations really stem from that. So if I know that to get this number, I divided the 5,280 by 12, I could have instead said feet in mile divide by 12. Or was it multiply by 12? Multiply by 12, right? And that gives us the same value, by the way. So I could have done the math here. And then, to determine the number of yards in a mile, I divided feet in mile. Divided, right? I divided, right, by 3 to get that value. And so what you're seeing here is really I only needed to look up one value, and this is really what the exercise is here, folks, is to recognize that partially. And yes, you could hard code the values here. I won't downgrade you for it at all. Because, as I said, if you're new to this, you probably aren't thinking that way. But an experienced program will see right away. It's like, why am I doing the calculations externally? I can just do it right inside the program. There's no reason not to. And then because this calculation will only happen once, right? It'll get stored here and it'll become a constant that will be unchanging, even if it's the result of an equation. And let's say I decided to switch, by the way, from doing miles. And this is really kind of weird. What's strange about the English measuring system, folks, is a mile on land is not equivalent to a mile at sea. And it's not equivalent to a mile in the air. And this is why people hate the old English measuring system is, metrics are different. A kilometer on the ground, a kilometer at sea, and a kilometer in the air are all the same. Isn't that fascinating? But the English system is not that way. So if I wanted to convert this, if I was doing nautical miles, this number would change, and then these would automatically change also, which I think is really fascinating. All right. However, let's not worry about that. We have our base calculations here. Now, what are we trying to determine ultimately, and what is the given value that we're trying to figure out? It says, also declare a variable to represent a number of miles and assign a value to it. Okay. And maybe what we're looking for here is maybe we'll just call this number of miles. That sounds, and that may be the number of miles you travel or will travel. So let's create a variable to hold that. And then in this case, I'm kind of thinking a little bit about what kind of variables to create. I'm thinking I'm still going to stick with an integer here, by the way. And I'm just going to call it number of miles. Now, because it is a variable, and not a constant, it's not all uppercase, so I'm only camel casing. It's only capital letters where the logical words begin. And I'm going to come up with some sort of a number here in miles. So I'm going to say I'm going to drive. I know that like my commute to work usually was about 36 and a half miles ballpark. But you know what? I don't want to use a decimal. I'll just say 36 miles. That's going to be my calculator, my given value. Now, the other thing I'm thinking about is what other pieces of information are we going to generate from this? And this is, compute and display with explanatory text the value in inches, feet, and yards. So I want to convert all of that and display it to the user. I have to do math, of course, to figure this out. So let's do the math part. And what I'm going to need ultimately is a calculation in inches, a calculation in feet, and a calculation in yards. And I need to name it something kind of clever here. And so I'm going to set up my variables to hold these values that we're going to generate. And then I have to think to myself, are any of these values going to come up as decimal numbers? Is that possible?
They shouldn't, because you're just going to be multiplying your constants of how much is in a mile to the number of your miles.
Right. And Lauren, that's a very astute observation. Some people would err on the side of caution here and create these variables I'm about to create them as doubles just to be on the safe side. But I know that that's not necessary because you're right. All the numbers that we're working with will multiply and divide into whatever evenly and display whole numbers. And that's kind of interesting. Now, Steve put a little interesting thing in the it says 1 degree in latitude equals 60 nautical miles. Yeah, somebody had to figure that out, Steve. And I'm glad it wasn't me. All right, so I'm going to create a series of 3 integers here. The first one is going to hold the number of feet. We don't know what the value is going to be. It's going to be calculated. We're going to have the number of inches. And the way that my mind is thinking, I'm going to actually come up here and add a line up here and say yards. And I didn't want to put that 0 in there, sorry. And so I'm going to say int number of, boy, I'm betting 1,000 here, yards. All unassigned, so yards, feet, and inches. All right, now comes the time to do the calculations. So let's first determine the number of yards, and we're going to use the variable number of yards. And that's going to be equal to what? Whatever the miles are, the number of miles. How do we determine that again? So how would we do this calculation? If I'm given a mile, how do I know how many yards are in it? And this is kind of one of the little puzzles here. So coach me. What do you guys think?
It's right there above. It's the same formulas that are above.
Ah. All right, so what could I do then, Dennis? You're on the right track. So,
well, if you got it, well, it's already doing the math. So can you just use the variable as the part of the equation?
okay. Well, this is going to be our variable. Right now it's hard-coded. But what you're saying is I could use one of these to help, right? So,
Well,
for example...
It's already doing some of the math up there.
Yeah. So we need... But how would I determine how many yards in a mile? Well, the feet in a mile is, however many feet there are divided by 3. Well, how do I get the feet in the mile? Well, that's a given. Right, so the number of miles, this is where it gets a little tricky. And some of you might have to resort to paper and pencil with this, by the way. And that's okay if that's what helps you get to the answer. Because we're trying to take this number of 18, and so let's talk through how to do this. So let's say I have 36 miles. Let's go to the calculator, and then maybe this will make more sense if I do it this way. If I have 36 miles I need to travel, that is... If I want to figure out the number of feet, all I have to do is multiply it by the number of feet in a mile, right? So I would say 36 times 5280. That's how I get that one. And maybe I should have done that one first. So then really all I'm doing is multiplying feet in mile times the miles. So you know what? Let's do that one first. So number of feet would be the number of miles times feet in mile. Okay, so that's one of them. Once again, let's come back to the calculator, and sometimes this gives us the inspiration we need, and that's why I do this, by the way. How would I determine the number of yards? If I know... Now, notice what I did before is I actually did 2 calculations here to get here, right? And so I took the feet in miles divided by 3. But to get the feet in miles, I had to multiply, I had to determine this. So 5280 divided by 3, right? Okay, so... First, I have to actually start with the 36, multiply by the 5280, oops, and then divide that by 3 to give me, does that seem like right? Is that right? And Ken, you're shaking your head. I saw you shake your head. Why is that not right? So I'm driving 63,000 yards to work. So like 633 football fields to get to work. That's the way to look at it, right? Third down and 63,000 miles to go. 63,000 yards to go. What do you think, folks?
I was just making my head spin.
I know, Jabari, I'm feeling you.
Like, are we converting it into, like, feet or yards or...
Well, you know what? We're trying to figure out the number of yards in my 36-mile commute. That's what we're trying to do. How many yards are in my 36-mile commute? And so this is why I did this math. And I think that this is kind of interesting. So I went 36 miles, and I know there's 5,280 feet in a mile. Okay, so somewhere I must have hit the wrong button, right? But if I divide that by 3, that is the right number.
Yeah.
Yeah, it is the right number. That's very, very coincidental, by the way, not planned. That is completely coincidental.
So 63,336 yards, right?
Right. But if you think about how I just did that, I took the number of miles, I multiplied it by the feet in a mile, so I can just copy this, right? And then I divided by 3. So here's what I want you guys to notice. When you do this kind of math, multiplication and division are equivalent functions. And so if I see a term that's already calculated, expressed in a different way, I could substitute here, in this spot, this expression, because it's the same thing. Or I could substitute this with that expression. So I could just simply do yards. It's already calculated, folks. So Dennis, you had the right answer.
Yeah.
But maybe didn't know how to express it. I could do that. Both functionally being the same equation. Now I'm going to put my semicolons in here, and then after this, I just want to give you the alternate part of this could be. You could also say this as number of yards equals, and maybe I should do this on the next line down. And then one thing we do is we could demonstrate it. Number of yards equals number of feet, which is calculated. And then what? Divide by. Well, that was the trick was divide by 3, right? That was the other way to do it. Because this part is already calculated. Now I'm just going to stick with the approach that I have here. Now let's do the last one, and as soon as we get done with this, I think we should take a break, right? Because I feel like people's heads hurting. It's not really supposed to be that hard, by the way. And don't, and the thing is, you might not get the math right, but we can always fix the math. It's more about how you're thinking about the whole problem. With the last one, we're going to do the number of inches. And the number of inches, so if we take that same, we go to the calculator again, if we take that same 36 miles and we multiply by 5,280, we get, that number that we already recognize. Now we would divide by 12 to get the 15,840. That would be the result, right? But let's talk about that expression again. What did we do here? We did the feet and miles multiplied here, right? But we're also recognizing that we can just multiply the feet and miles by 12, right, which is the same as this calculation. So how would I express this one? Anybody have an idea?
You could just keep going like you were before, just do your number of miles times your inches a mile.
Okay, so this is Lauren's suggestion, and the number of miles. So let's test this, right? Because really, this is built in. So this is the 5,280. So it's all going to work, right? So really, what this is doing is it's multiplying by 5,280 and then multiplying by 12, and it's all about the simplification. Some of you would recognize that, I don't need to put any of this in here, but the only thing is the instructions asked you to, and that's why we're doing it. So you could hard code those values in here. It's all about rewriting into different terms. So now let's just do a quick system out here. Do system dot out dot print line and take this the rest of the way and finish this up. All right, so I'm going to come in here and create my double quotes here, and I'm trying to think of a really kind of a concise way to say this. I can say that. How about this? Number of miles, whatever I entered. $32 miles is equal to, so watch my approach here, and now I'm going to go to another line. Instead of like trying to squeeze everything and actually see number of miles, would just put 36. I would say 36 miles is equal to, and so I'm going to copy the system out print line statement here to get myself started, is equal to. Okay, so what are we going to put on here first? Number of feet and do I really need to say anything else? No. And then the subsequent lines will kind of basically follow the same pattern. Here we're going to say number of yards. And then finally, yes, I'm going to clean this up, so don't worry about the layout of this. We're going to switch this to inches. And just change the label. And then, of course, whenever I write anything like this that has calculations in it, I'm going to verify every calculation, by the way, beforehand, like with the calculator. Or if you like to use a spreadsheet or pencil and paper, whatever it is, you want to validate that. All right, so here is, so far, the completed code. All right, let's go ahead and save and run this. So I'm going to run this now, and let's take a look at the output. And it says, "Oops, I got a error." Oh, okay. In the file name. Mile conversions. Let's try that again. All right, one more time. All right. And I got all sorts of issues here, folks. So let's see.
On line 7, you have the I in miles capitalized.
Ah, thank you, Laren. All right, one more time. Save and run. And see, it's great when I make mistakes because then you guys don't feel bad about making yours, right? Now, 36 miles is equal to. Did we verify the number of feet? Well, this is what I would do. I would pull out the calculator and just make sure that 36 times 5280 indeed is that. 6330 yards. I shouldn't have deleted that. So 36 times 5280, right? And that would be divided by 3. That's the right number of yards. 36 times 5280 times 12, and that looks correct for inches. All right. So I'm just going to leave this on the screen. We are going to go to a break, folks. But for those of you that are still working on it, there's the code. I'll leave the screen share active. But we are going on a 5-minute break. So I'll see you guys in 5 minutes, okay? All right, we're back from break, and we're going to move on to the next exercise. So let's go see which one that is in the book. And we are going to do this one here, exercises 8 and 9, which are... Oh, wait a second. We didn't do the second part of number 6, did we? All right, so let's do that. I'm going to start by first doing this little piece. I'm going to copy the file name. I'm going to go back.
You also can't see your screen again, Ty.
Oh, thank you. Right, the recorder is catching it, but you guys aren't seeing it, so here I go, sharing my screen. This is becoming a bad habit, Laren, is what it is. But at least somebody's there to tell me. All right. So the first thing we're going to do is we're going to do a save as on this. And this time I'm not going to change the name right away and see if it flags it at all. And notice, save anyway, even though I don't change it, or save with the expected name. And if I do that, by the way, it'll switch it back to the name it already was. So I'm going to go ahead and choose save anyway, and then come up here and change this to match. So mile conversions interactive. Now the same way that we did the last interactive exercise, we're going to bring in the scanner. So I'm just going to copy paste this stuff, folks, one at a time. So let's put the scanner at the top, add a couple lines and do the import. Next we're going to go back to the other program and grab the scanner class instantiation and the prompt and the variable name. We'll tweak it, but we're going to copy all that so we can save a little bit of typing. And then we're going to drop it in basically in the same spot. Now remember, the reason that we're doing this is to not have to hard code the number of miles, to allow whoever it is to put in the number of miles themselves. So we're going to delete this value like so. Next thing we're doing is going to change the message so it matches what we're doing. Maybe this is like the calculator for the number of work miles. So please enter the number of miles it takes to get to work. That's a good way to do it. The variable that we're feeding it into, of course, is going to be this one. So I'm just going to double click and copy and then paste it over this one. And I want you to notice why I do that. The reason I do that, and this is a habit, is I don't want to mistype it, right? So if I copy it from where I created it, I can't mistype it. And this is a strategy, folks. Once again, when we switch over to Eclipse, you'll notice Eclipse, as you start typing a variable name, will auto-suggest and complete it for you, which is one of the reasons why I like switching to it. It also helps to prevent errors. We are working with all integers here, so I think this is all going to be good. And if you've made these changes, so the scanner at the top, making a scanner class called input, giving a prompt, and then storing whatever we get from the keyboard into a variable is all the changes we made. So I'm going to save, and we're going to go ahead and run this, and let's bring up the console here so we can see the output. It says, please enter the number of miles it takes, we got to put an S there, to get to work. And so we already tried, 36. Somebody tell me how many miles you have to drive to work. Anybody?
0.
Okay. Well, that won't be a very exciting calculation, Laren. How about somebody else? How many miles do you drive to work?
23.
23. All right, 23 miles. And it's 23 miles is equal to 121,440 feet, 40,480 yards, and 1,457,280 inches, by the way.
That's when the traffic's bad. It's in inches.
Yeah, that's what it feels like. It's even farther, right?
It's in inches.
Yeah, and that, and that's the thing. If anything, what the pandemic has done for us is taught a lot of companies that people can work from home and be just as effective, and go to school and be just as effective without having to waste a lot of resources on traveling. And in some ways, I hope some of that sticks around, because I think it's so much better. And for some, it's better for your pockets. It's better for the environment. It's better for the traffic on the streets, right? So the more people that work from home, Dennis, the less traffic hassles you have on the way to work. And I don't know if any of you have noticed that. I don't commute anymore, so I don't notice it at all. All right, now let's move to the next exercise.
And also, when you rename this to Miles Conversation Interactive, right? That's what you did.
Yes.
And then it showed this sign, right? I was saying either save anyway, save with expected name.
Yeah, if I would have chose expected name, it would have switched the name back to what the class was. I chose to save anyway, so the first time I did it, I came in here and changed the class name first and then saved the file. And it was okay. This time I did it the other way around. I didn't change the class name and put in a different file name, and it was like, hey, you're doing something wrong. Do you know what you're doing? Which is save anyway. And then save with expected name would have saved it back to the class name, Jabari. Just make sure whatever you name the file, that the class and the file names match. So for this one, they should both say interactive. Okay?
Okay, I just did that.
Okay. All right, let's move on to the next exercise so we can get another one of these done before the night ends here. All right, so this next one is called inches to feet, and then the follow-up inches to feet interactive. So let's read what this says. It says, write a program that declares a variable named inches, which holds a length in inches and assign a value. Display the value in feet and inches. For example, 86 inches becomes 7 feet 2 inches. Be sure to use a named constant where appropriate. So at this point, they're kind of thinking that we've got this kind of figured out, by the way. That's kind of how they're approaching it. And so I'm going to begin again by just creating our program. So let's do that part of it. Let's go back to JGrasp, and we'll create a new Java program. This one is going to be called inches to feet. So let's do a save as right away. Or actually, let's do it like this. And Jabari, this will help with what you were just asking about. So we're going to say public class inches to feet using camel casing. And then let's open and close our curly brackets right away. Now let's do a save as. And then watch how it will automatically pick up that name. Right? And if I change this in any way and try to save, this is where you get the message. So if I save with the expected name, it'll fix it. If I click save anyway, it won't. But I'm going to click save with expected name. Then I want you to notice that it fixed it. Okay. Now that we have the class declaration, now let's come up, indent, and put in our main method. So public static void main, parens, we will do string, square brackets, args, and once again another set of curly brackets like so. And we're ready to write our code. Now this one is going to be a lot easier compared to the one that we just did. It's kind of the same type of exercise, honestly. They want us to create a constant. And what is the constant here?
If there's 12 inches in a foot.
Inches.
Yeah, there you go. So I'm just going to say inches per foot. All caps. And the value for that, of course, is 12 inches per foot. Now we are going to calculate, for example, how many inches there are. And actually, we're gonna hard code that at first, right? I think they did this. I think they said you're going to give it some inches, and for example, they put in 86 inches. So we're going to hard code that at first. We'll make this interactive afterwards. Okay, after we get it working, basically. And then the outcome of this will show us how many feet there are, which we're not going to preset. And then we're also going to figure out how many inches are left over, if you will. So if I divide this by 12, I'll get a certain number of feet, and then I'll have a remainder of what's left over. So we're going to calculate that. Now, part of what I just said is kind of the answer itself. So one of the first calculations we're going to do is this one, and I'm just going to paste it in to kind of speed things up a little bit here. So we're going to determine the number of feet by simply dividing the inches by the inches per foot. And yes, I could have hard-coded 12 here, but the point is that you learn how to use constants. Okay? The next calculation is we also have to figure out, like we did with the quarts and the gallons, how many inches are left over, what the remainder is. And if you guys remember how we did that, it's really the same calculation, but we're determining this variable. So I'm going to copy this one down, and then we're going to use the same division but we're going to change the operator once again to the modulus, which is going to give us just the remainder. Okay? But it's basically the same calculation. This one gives us how many times it goes in. This one gives us what the remainder is. And then our output statement can actually be something kind of simple. And so I'm going to go ahead, and once again, just to save time here, because I'm watching the clock, is I'm going to paste in this statement. So we're going to just put out a statement that says, for example, 86 inches is so many feet and so many inches. Let's go ahead and run this one. And I'm just going to go straight to the run button. It will automatically save. And if we did it correctly, it should give us the output message. And you can see 86 inches is 7 feet and 2 inches. And that is correct, right? Anybody not know that math? Like, we can always validate it with a calculator if you're not sure. And if you're not sure, real honestly, folks, you should check it, before you trust it. All right. So the next aspect of this is to create the interactive component. So once again, we're just going to come up here. We're going to change the name this time. And now we're going to go straight to a save as. It will pick up the name correctly, and we will save it. You notice why it's better to do it this way. Change the name and then save it, because it automatically negotiates it. That's how JGrasp does it, by the way. Other programs do handle this differently, and I want you to be aware of that. So don't expect every program to act like JGrasp. Okay. So now that
you might end up saving over one you don't want to save over.
Steve, that's an excellent point, right? Because you don't want to overwrite your work. And you notice that all of mine, because I did save as's, I don't have the original ones there. I just have the interactive ones left. Okay, so that's one of the other things. Now, there is a choice on most menus in these programs where sometimes you can save copy as. I don't see that option here. But I wonder if the backup as, I think, is really that one. So I could go backup as and create another. I'm not really worried about that feature here, frankly. All right, let's add the scanner again. So I'm going to come over here, and from my other screen, I copied in the scanner statement. So we're going to do the import. Apparently I didn't hit copy well enough. There's the copy. We're also going to drop in the same statements that we've been doing all along. And that is, and I'm just pasting it all in at once, by the way. We're adding our scanner. We're putting a message on the screen, how many total inches, and then we're storing whatever we get into the variable called inches, which was preset, but I'm going to remove that preset. Now, I'm going to tell you that one thing that some programmers are doing, this is just more informative than anything else, is some people are very uncomfortable about putting in variables and not assigning values. Because if they do something in the program and they forget to assign a value and they call on something, it can cause errors. So some people will preset everything to 0, for example, or some given default. I'm not doing that because I know I'm going to be careful about making sure that I populate those things. But no other changes are really needed to make this go. This is what the whole thing looks like with the scanner put in, the import, the prompt, and grabbing the value from the keyboard. Now we're going to allow the user to put in the inches. And you know what? This is one of those things that, people that, carpenters, for example, they know how to convert feet to inches pretty quickly because they do it all the time, right? But us normal people, once we get past 2 feet or 3 feet, we start forgetting how to divide by 12. And so this is actually can be a pretty useful little program. And so let's put in a number that's a little bit larger here. How many total inches? I'm going to say 104 inches. So how many feet is that, folks? Quick. Too late. Right? And that's the kind of math you should be able to do, but a lot of us forget. Okay, so 8 feet is 96 inches plus another 8 to give us 104. Is that the correct calculation? Well, I would check it with a calculator. But here's an example of the program working. And of course, I always tell people, especially when we do the interactive part of it, test it. Put in values you know So we know that 12 inches is 1 foot. And we know that if we have, let's say, 26 inches, that's 2 feet 2 inches. And put in values that you know and see what happens. Now, the other thing that might happen as you're at the keyboard, by the way, is what happens if you accidentally type in a string here. Oh yeah, then you got a problem, right? It crashes. What happens if you run this program again and you put in a decimal number when it's not built to accept it? It also will crash. And so that at this point in our program development, by the way, we're not worried about checking the input. We're just making sure, hopefully that they put in the right number and it comes out the right way. But when we get to more advanced levels of programming, what we'll do is we'll put in code that will prevent them from putting in the wrong kind of input. Or give them a message saying, please enter a whole number. That type of thing. Right? There's also other ways where we can, adjust things automatically as well. But I'm just pointing this out because some of you will mistype and then you'll think that maybe there's a problem in your program. And the reality is there's no problem. We just didn't design it to accept strings and decimal numbers. Just integers. But once again, test it with values you know. So 4 feet 4 inches is 52 inches. All right, let's move on to the next one. I think we're making some good progress here. We got that one done in like 10 minutes flat. Much better than some of the first ones. I'm going to check here. I'm going to go back to Blackboard. Can somebody tell me what the next exercise is? Is it number 11? Or are we doing number 10 also?
I think we were doing it was like 4 through 11 through, it was 4 and 5, 6 and 7, 8, 9, 10 and 11.
Okay. So 10 and 11 are the next two that we're doing. All right, so this one's going to be a pretty easy one compared to some of the ones that we've been doing, but the whole point of it is write a program that declares variables to hold your 3 initials. Display the 3 initials with a period following each one. And so this one it should go pretty quick. So let's go ahead once again and create a new program. I think they called it initials. Okay, we'll just call it initials. We're going to say public class initials with a capital I and then our curly brackets. Let's do a save as right away. Picks up the name automatically. And then I'm going to create a little space here, and once again, following our usual pattern, we're going to add the main method. Are you guys getting to the point where you're starting to memorize this part? Did I mention it'll probably be on a test? Which one is the right one? You should know.
String instead of static.
Well, or whatever. Yeah, whatever is appropriate. But this statement for now.
You wrote string instead of static.
Oh.
Or static instead of string.
See? I'm just testing you guys. See, my fingers did that automatically. I wasn't even thinking. But that little piece you guys have to memorize. Okay? Out of all little weird statements in Java. All right. Now we're going to declare variables. And it didn't say anything about integers or constants. You guys notice that? But in the variable types that we have learned so far, there's only one of them that allows us to store characters. Do you guys remember which one that is?
Char?
Yeah, char, and that's usually how most people say it. And so this is a special variable type that can only hold one character. This is kind of interesting because Java is one of the few languages that really breaks it down like this. And we're going to call it first initial. Okay, and what's my first initial? My first initial is T. And then we're going to create another one called middle initial. And my middle initial is G. And then finally, my last initial, if you call it that, is K. Just like that. And the only trick of this one is putting it back on the screen. And also orchestrating the fact that, the key to this one is to recognize that there's this data type that is only capable of holding one character, and then to output it in something more robust with added punctuation to it. So we're just going to do this on one single print line statement. And so this one, ends up being pretty darn easy. So what I would do is do it like this. And so I'm trying to be verbose with the output. Right. You guys notice how I put in a single apostrophe in there? You think there'll be any problems with that? We'll see. What if I did this? Still okay, actually, by the way. Did you guys also know, and we haven't really talked about this, I don't have to use double quotes here. I could use single quotes on both ends. That's perfectly legal also. But if you're doing that, then this interior one has to change. You can't do it. And you see how it's not liking it either. So I'm just going to revert back to what I had. So I'm just control-Zing my way out, by the way. And so now we're just going to say first initial plus a period. I'm going to go down to the next line, by the way, because I'm running out of space already. Plus middle initial, plus that period again. So I can just copy this, I suppose, if I don't want to type it. So laborious. And then finally, the last initial. And the technique that I'm using where I'm copy pasting instead of manually typing it is, once again, a habit developed from writing code and not wanting to put in the wrong stuff and then fix it in the aftermath. Okay, and that's a really important takeaway. This is all there is to this one, folks. This is a piece of cake, right? The big takeaway here is the character thing where it can only hold one. So some people will come in here and put in the periods, and then they discover, no, you can't put in two values there. And then practice outputting to the screen using concatenation symbols and variable names. All right, save this and run it. And I have a mistake. So what did I do wrong?
Because I know the difference that I'm seeing when I'm looking back at what I've coded is I just use like the single quote instead of the double quote.
Right, and Lauren, this is exactly the point of why I did this. The character declaration requires a single quote. So let's change all these to single quotes and see if that makes a difference. Saving, and once again running the program. Okay, so that's an important takeaway too. So when you do the character declaration prefers single quotes around the character. And the reason that this happens is otherwise people start to think that they're working with a regular string, and this is why. So most people usually go to double quotes first when putting strings on the screen. And the character declaration, because it's what we call a primitive data type, where only a single character can exist, is done this way, just to create differentiation in Java. Right? I want you to keep in mind, too, that in other programming languages, like in Python, for example, or JavaScript, this is not a convention at all, because they don't have this as a primitive data type. There are other languages, though, like the original C languages, that do have this convention also. And they exist for very specific reasons, because the reality is when we are constructing a string of characters, they are exactly that. They are individual collection of individual characters strung together, which is why we get the name string. Right? And we'll talk about that in the next chapter, by the way. All right, so that was exercise 10. Now we have one more. So let's keep moving along here, because we are going to finish this tonight, which is fantastic. This is the last exercise, correct? Okay. And this one is called eggs, by the way. And I like this one because it has you do a little bit of thinking. And there's a little bit of math required, but it's pretty logical. So I'm going to show you the math, so don't freak out to that part of it. It's not very complicated in any way, shape, or form. But let's read the exercise. It says, Meadowdale Dairy Farm sells organic brown eggs to local customers. It charges $3.25 for a dozen eggs or 45 cents for individual eggs that are not part of a dozen. Write a program that prompts the user for the number of eggs in the order and then display the amount owed with a full explanation. For example, typical output might be, you ordered 27 eggs. That's 2 dozen at $3.25 per dozen and 3 loose eggs at 45 cents each for a total of $7.85. And so now if you start to break this down, and this is, part of the exercise here is to think a little bit about what's going on here. What variables do I need? What values might I have to hard code? What values could I allow the user to enter? How will I grab that input? So this is an interactive program right from the get-go, so that's an important thing to note right there. All right, the name is really easy. It's called eggs. Let's go ahead and create this for starters. So let's come up here and create a new file. And we are going to do our public class eggs with a capital E, open and closing curlies, and a save. We'll let the auto file generator there do its work, and then we'll come back and make our main method. Let's see if I can mistype this again. Public static, should I say public string void static? Public static void main. Inside, we have string, square brackets, args, and then another set of curly brackets. Now, right away we know that we are going to be prompting the user, by the way, for this. But what they were trying to establish in the book, and I don't know if you guys caught on to this, is they kind of recommend that when you do something like this where you might be prompting somebody to enter like 27 eggs, you might want to actually start by coding it without the prompt and then add the prompt after. Now I'm going to be brave and I'm going to go right to the prompt because I think we've done enough of it where we're kind of used to it. So I'm going to pre-build that piece in. So I am going to go back and I'm going to grab the import and put that at the top. And remember, you don't have to use it. You could always comment it out if you want to work in that fashion. And then I'm also going to grab the scanner. I know that it's going to have errors to begin with, but we will fix that. We'll leave some space here to add variables, but we will put the scanner statement here, and we will say how many eggs would you like? And, maybe it's even better, if you want to really be verbose about this, how many single eggs would you like? Because a lot of people think in dozens for eggs. And I think whatever we capture here, this might make sense to just be called eggs. So I'm just going to copy that, and I'm going to pre-create a variable right away to hold it. So int eggs, and that will be populated by this. All right. Let's talk about some possible constants here. What are some possible constants?
Eggs in a dozen.
Perfect. So we can actually predefine dozen if you wanted to make it even simpler and just say dozen equals 12. So every time I want to use the number 12, I just say the word dozen in all caps. What's another value that might be considered hard-coded here?
The price for a dozen eggs.
Right. And notice how I'm switching this now to a double, right? Because we're dealing with dollars and cents, so there is a decimal point. And we're going to call it price per dozen. And verbose is preferred in these situations, and we're going to hard code 3.25. And if the price of eggs go up, we come in, change the code, and it'll auto-calculate. That's one of the reasons why we do it this way. What else? There's another one that needs to be done the same way.
Single egg.
Single egg. Very good. So price, double, and we could go say price each. How about that? You could say price per egg, I suppose. And this is going to be 45 cents. All right. We have our variable here to capture input. I'm going to kind of get rid of this blank line here. And then, are there other variables we should create? Well, here's what we do. We look back at the program, and they want us to determine by, let's say if I said I want 99 eggs, that will tell me, kind of like the paint thing, right? How many dozens. So I need something to hold that. So dozens would be an integer. And notice how this is lowercase and plural, so I can keep them straight. We're also going to need to know how many single eggs are left over from that calculation. That's another one. And then also, how much money they owe us for the eggs. So we're going to create a double for that called total. And it's very common whenever you're doing, financial calculations that usually they're stored in a variable of type double. It's one of the most flexible numeric structures, by the way. Let me create a little bit of screen space here so we can see what we have so far. I am going to do a Control S to save. I don't want to lose what I have so far because that's, a bit of code. All right. Next thing that we have to do is, at some point we have to put the information back on the screen. But first, let's do our calculations. And the calculations for this really aren't as complicated as you might think. So if somebody enters, let's say hypothetically, 99 eggs, the first thing we're going to figure out is how many dozens that equates to, very much like the paint. So we're going to use that variable we created called dozens to figure it out, and we're going to say the number of eggs they entered divided by the hard-coded dozen. And some people would just type a 12 here, yes. But we're using this. We're also going to calculate the number of single eggs that are left over. And this calculation is similar to all the stuff that we've done before. Once again, we're going to use the same division, and we're looking for the remainder. And the reason we do this over and over in this chapter is a lot of people don't see the reason why we have modulus. And I'm showing you why. It really is a very logical thing. And it was originally developed when they started to do cash register calculations, by the way. That's why modulus was or making change is another reason why they developed that operator. All right. Then finally, based upon what we determined here, now we need to actually figure out how much they owe us. So here's the statement. I'm just going to paste this one in really quick. And so here's the calculation. So however many dozens we've determined, we're going to multiply that by the price per dozen. However many single eggs we've determined, we're going to multiply that by the price each. We're only going to do that for the ones that don't fit into a carton, basically. Right? And the beauty of this is if I decide later to change the price for a dozen and a single egg, I only have to change it here, and then the whole rest of the program will auto-adjust, which is the beauty and why you use the constants in the first place. Okay, next step. Now we're going to do our output, and we're going to do something different with our output this time. And once again, I'm going to paste this all in because I'm looking at the clock and I know we're basically out of time. And I want to bring the class to a close. And this relates to Appendix C in the book. So I'm just going to make this little note here. C, Appendix C, which talks about formatting. And so what I want you to do, and I should probably add it to the readings for this chapter, but if you go to that chapter, they talk about this command here. So instead of doing a print line, we're doing formatted print. And so it works very much the same way as a traditional print line statement, except when we get to the point of putting out numbers, like, for example, the total, notice that at the end here there's a comma, And then right before it, there is this really quirky collection of characters, which for right now you can just copy to try it the first time. But this is a special formatting command that, by the way, is not original to Java. It's actually original to the C programming language. And those of you that were in the Python class previously will recognize this too, because we did the same thing in the Python class. And in fact, the syntax is identical because it uses the exact same libraries to generate the formatted output, by the way. So it's shared by Python, shared by C, shared by Java. Kind of interesting. But this will format it in the form of dollars and cents like we're used to. So for example, the $sign will appear as text. The % sign will be populated by the total, followed by 2 decimal places. And then this is the formatting command, and then we issue a new line command to drop us to the next line. Okay, so let's run this and take a look at how it looks. All right, you guys, I know, are probably racing to grab the code. You can always screen grab this too if you're crafty. All right, so I'm going to go ahead and run this, folks. And I'm going to pull the console up so we can see the whole output. How many single eggs would you like? Well, first thing I'm going to do is I'm going to look at the book example. So this person did 27 eggs, so it should be output that looks just like this. So it should be $7.85. So what was it, 27 eggs? And, well, it does go off the edge of the screen. All right, so that's maybe that's a little bit problematic. So what I might do is I might put a new line command right before the word and. That might be a good thing to do. In fact, let's do that so you can get some practice with that. And these are special characters, by the way, called escape sequences. And we put those in. So whenever I do \n, that will push the content to the next line. Let's try this one more time. Save it and run it. Put in the same number, and there's your output. Now let's try a different number. Let's try something significantly larger. Let's put in 99. That's a number I've been throwing around. So if you know of your division, how many dozens is that? Correct, 8. Right, I'm sure you guys all had that at the tip of your tongue. But 8 dozen times 325, and once again, it's smart to validate this in a calculator, and so I don't believe it necessarily, so I'm going to go 99 divided by 12 is 8, and I got, well, whatever the 0.25 is, but 8 times 3.25 is 26, and then if I have 3 single eggs left over times 45 cents, I would multiply that by 0.45, I got $1.35, plus what did I come up with, 26? All right, so the numbers are good. But whenever you write a program for the first time, you always, even if you think your program is written correctly, always go in and double check to make sure that what you're getting is correct. Don't just assume it is. And that's a word to the wise, and it comes from experience, by the way. Because the last thing you want is a program that you put out to the public that does not calculate correctly. All right, folks, that's all for tonight. I'm going to stop my recording now, and then I'm going to just really quick